Good morning. Welcome to the lecture on Cauchy's theorem. Green's theorem in a plane. The statement is given by if R is a closed region of the xy plane bounded by a simple closed curve C, and if m and n are two continuous functions of x and y having continuous partial derivatives in the region R, then integral m dx plus n dy is given by double integration of dou n by dou x minus dou m by dou y of dx into dy. This theorem we will be using it while solving the problems. Cauchy's theorem. Statement: if f of z is analytic at all the points inside and on the closed curve C, then integral of f of z into dz is equal to 0. Proof: let f of z equal to u plus iv is analytic, which implies on integration along the curve C, f of z dz is integral u plus iv of dz will be dx plus I dy. This implies integral along C, f of z dz is equal to on multiplication and separating the real and imaginary parts, we get u dx minus v dy, that is the real part, plus I times of integral v dx plus u dy, that is the imaginary part. So let us call this as equation 1. Expanding the equation 1 by using Green's theorem in a plane, it states that integral m dx plus n dy is equal to double integral of dou n by dou x minus dou m by dou y of dx into dy. So the equation 1 implies integral along C, f of z into dz is double integral along the region minus dou v by dou x minus dou u by dou y of dx into dy plus I into double integral of along the R region dou u by dou x minus dou v by dou y of dx into dy. Since it is analytic, we have from CR equations dou u by dou x is equal to dou v by dou y, and dou v by dou x is equal to minus dou u by dou y. Substituting, f of z dz along the integral along the curve C is equal to double integral along R minus dou v by dou x plus dou v by dou x of dx into dy plus I times of double integral along r dou u by dou x minus dou u by dou x of dx dy. That is, by substituting the CR equations, both the terms in the right hand side, that is a real part as well the imaginary parts, will become 0. Therefore, we get the integral along C f of z dz is equal to 0 plus I 0, which implies integral along C f of z dz is equal to 0. Consequence number 1. If f of z is analytic in a region R and if P and Q are any two points in it, then integral from P to Q f of z dz is independent of the path joining P and Q. That is, integral from P to Q f of z dz is same for all curves joining P and Q. The curve which is represented in the diagram, it is a curve A is from P to Q and curve B, that is C2, is from P to Q. That is, integral along the curve C1 of f of z dz is equal to integral along C2 of f of z dz. Second consequence, if C1 and C2 are two simple closed curves such that C2 lies entirely within C1, and if f of z is analytic on C1, C2 and in the region bounded by C1 and C2, then integral along C1 f of z dz is equal to integral along C2 f of z dz. Consequence number 3. If C is a simple closed curve enclosing non-overlapping simple closed curves C1, C2, etc. Cn, and if f of z is analytic in the annular region between C and these curves, then integral along C is given by integral along C1 f of z dz plus integral along C2 f of z dz plus etc. integral along Cn f of z dz. This is the consequence number 3. The diagram is as shown below. Thank you.